In this example, we want to find the absolute maximum and absolute minimum of the function of x equals to x all divided by x squared minus x plus 25 on the interval from 0 to 15. Okay, so we're only going to look, we're only going to find these, find the max and min with respect to this interval, okay, where the interval is given from 0 to 15. Okay, so the first step that we want to do is find our critical numbers, okay? Okay, so we have a function, a continuous, we have a function, in this case it's a continuous function, and it's on a closed interval from 0 to 15. Okay, so that means the max and minimum values will either occur at the boundary points or at the critical numbers. Okay, so to find the critical numbers, remember that we need to set the derivative of the function equal to 0. Okay, so let's go ahead and do that. In this case, we need to go ahead and apply the quotient rule since our function is a rational function. Okay, so we're going to have f prime of x, so the derivative of f with respect to x. So we're going to have the derivative of the top, okay, times the bottom minus the derivative of the bottom times the top. And all this is going to be divided by the denominator squared. So we're going to have x squared minus x plus 25 squared. Okay. So this is going to give us, okay, we have the derivative of x, which is just 1, so that's going to have x squared minus x plus 25 minus the derivative of x squared minus x plus 25 will be, this is going to give us 2x minus 1 times x. And all this is divided by x squared minus x plus 25 squared. Okay. All right, so let's go ahead and simplify this and then solve for critical numbers. Okay, so looking in the numerator, okay, we can simplify this. This is going to be, we have x squared minus x plus 25 minus, okay, I'm going to go ahead and distribute the negative, so we have minus 2x squared. Okay, so just distributing the x here. So we have minus 2x squared and then plus x. And all that's divided by x squared minus x plus 25 squared. Okay, so we're going to get, let's see, minus x squared. Okay. Minus x squared plus 25. Okay, all divided by x squared minus x plus 25 squared. Okay. All right. So that's the first derivative. Okay. So we're going to go ahead and set that equal to 0. So when we set this equal to 0, okay, again, we just need to look in the numerator. Okay. So that's going to give us, okay, let's go down here. So that's going to give us minus x squared plus 25 equal to 0, which is equivalent to x squared equals to 25, and that will give us x equals to plus or minus 5. Okay. All right, so there's our critical numbers. However, we're only interested in looking between 0 and 15. Okay, so we just need to, so we're just going to have a critical number of 5 here. Okay, okay, so we're just going to look at x equals to 5. Okay. All right. So -5, again, -5 is not in the interval between 0 and 15, so that's why we look at 5. Okay. All right. Okay, let me move this down. Okay, so the next step is to evaluate. Okay, we want to evaluate the critical numbers at our function and the boundary points. Okay. And the boundary points. In this case, our critical number is 5, and our boundary points are 0 and 15. Okay. All right, so we're going to have f of 0. Okay. So remember, our function is, right, it's x over x squared minus x plus 25. Okay. Okay, so f of 0, obviously that's going to give us 0. We plug in 0, we're going to get 0 in the numerator, divided by 25, so that gives us 0. And then let's go ahead and evaluate the function at 5. Okay, so we're going to have 5 over 5 squared minus 5 plus 25. Okay, and that's going to give us, when we simplify this, okay, we're going to get 1/9. Okay, so right, because we have this value of, so we have 5 over, just check my work here. Okay, we have 5, yeah. So that's going to give us 1/9, okay. After we reduce it, okay, and then for the next one we have f of 15, okay. So we have 15 divided by 15 squared minus 15 plus 25. Okay. And so we end up getting 15 over 235, and that reduces to 3 over 47. Okay. Okay, so we should also look at the denominator of our derivative, okay, to see if we're dividing by any possible 0 here. Okay, so looking at this part here, okay, it turns out that there is no x value that will make that 0. Okay, the reason is because if we look at the discriminant of this, okay, so this is a quadratic, right? And so the discriminant is b squared minus 4ac, okay, where b is -1, and a is 1, and c is 25, okay. So this gives us a value of -99, and that is less than 0. So if the discriminant is less than 0, that tells us that we have this function will not cross the x-axis. Okay, so there's no real roots for this function. Okay, so therefore there is no x value that makes this 0. Okay, all right. So the only critical number we have is 5. Okay. All right. So now from here we're going to compare, right? So then that's the third step, is that we need to compare the y values, right? Okay. So we choose the smallest number will be the absolute minimum, the largest number, the largest y value will be the absolute maximum. Okay. All right, so we have at f of 0 we had 0, so this is going to be the minimum. Okay. Okay, and here we have 1/9. 1/9 is bigger than 3/7, so that is an absolute maximum. Okay. Okay, again, so this is right. So this is an absolute. So we have an absolute minimum at 0. Okay. Okay, so there's one at 0, 0, and an absolute maximum at occurring at x equals to 5. So, and the y value for that was 1/9. Okay. All right. All right. So to the left of, or to the right of this, we have the graph. Right. So this is x, this is y. So here's the graph of the given function. Okay. So you can see, looking between 0 and 15. Okay. Okay. So looking between 0 and 15, we can see that there's an absolute minimum here, and at the value of 5, okay, which is about here, okay, we get, right, we had 5 1/9. Okay, here was just the origin. Okay, so at that point, at the origin, we have a minimum, the absolute minimum on this interval, and at 5, we have an absolute maximum. Okay, so that's the solution for this problem. Okay, so again, we have absolute minimum at the origin and absolute maximum at 5 1/9. Okay.